All right. Hi, everyone. Welcome to my channel, Math Made Easy with Terry in 10 minutes. So the last time we'll be talking about Pascal's triangle, and now we're going to talk about binomial expansion with positive whole numbers powers, okay? So first and first is, for instance, if we wanted to expand the binomial expansion, let's say we have 1 plus x raised to the power 40, for instance. Try to imagine the kind of stress and how cumbersome it would be for us to draw a Pascal triangle that will be that big. Does that make sense? Till we get to power 40. So therefore, the use of Pascal triangle will not be recommended here. I will need to generate a large number of rows of triangles before we get to the integer of 40. This is where the binomial theorem kicks in, okay? So in binomial theorem, where n is a positive whole number, so like I'm trying to say in this video, the only thing we're talking about here is for positive whole numbers, okay? So only when the n is positive, so like 1, 2, 3, 4, 5, 6, 40, and the rest of it, that is when you can use this, okay? Now, it still follows the same principle, okay? You're gonna have a to the power n, like the previous video, and b raised to the power 0, okay, plus you have a raised to the power n minus 1, okay, then b raised to the power 1, like the previous video, that as you keep on going, the power of the first one keep on decreasing, then plus a raised to the power n minus 2, b raised to the power 2, and you keep on going up till when you get a raised to the power 0, and b will be raised to the power n. Okay. Now, but the coefficients, in the Pascal triangle, we use the Pascal triangle to get the coefficients for each of this. But in this case, to get the coefficient, we use what we call combination. Okay. I'm going to upload some videos on combination and permutation. So if you're not conversant with it, please go back and have a look. But the combination, you can use your calculator to calculate it as well. So for the first one, it's going to be n combination 0. The second one will be n combination 1. So you keep on going, n combination 2 till you get to n combination what? N. Okay? And this is what we call the binomial theorem formula. So that means it's n combination 0, a raised to the power n, b raised to the power 0 plus n combination 1, a n minus 1, b raised to the power 1, n combination 2, sorry, not n combination 2, n combination 2, a raised to the power n minus 2, and the rest of it, okay? And this is it. And that is the trick about it. So for instance, if we have, let's do an example now, okay? Let's say we have 1 plus x to the power 3, okay? I want to use combination, binomial theorem to do this. So it's going to be, as usual, it's going to be 1 to the power 3 and x to the power what? 0. Does that make sense? Plus 1 to the power 2, x to the power what? 1, do you remember? Plus 1 to the power 1 and x to the power what? 2. So remember I said as you keep going, the first one keep on decreasing while the second one keep on increasing, okay? Plus the last one is going to be 1 raised to the power 0, okay? Put this in bracket as well so it'll be easy. And x raised to the power what? 3. Now, to then find the combination that is for the coefficients now, the same thing. We'll now put it there. So it's going to be the same thing. It's going to be n, is right? Our n here is 3, so it's going to be 3 combination 0, 3 combination 1, 3 combination 2, and 3 combination what? 3. Is that making sense? Now you go to your calculator and you press in your calculator. 3 combination 1, that should give you 1 times 1 raised to the power 3 should give you 1. I remember I told you in the previous video, anything raised to the power 0 is going to give you 1. Okay, anything raised to the power 0 is going to give you what? 1. So times what? 1 plus Now, when you press your calculator, 3 combination 1 will give you 3 times 1 times x plus. When you press your calculator as well, 3 combination 2 will give you 3. So for the combination, you don't need to stress yourself. You can press your calculator. In most calculator, it's going to be shift divide, okay, to get the combination. Most calculators shift divide, but you just need to check with the manufacturer. So just Google your calculator online to see how do you use combination in your with your calculator, okay? So that will give you 1 times x2, all right, plus 3 combination 3. When you press your calculator, it's going to give you 1, and this already 1 times x raised to power 3 is going to give you x3. Then you simplify, it's going to give you 1 plus, it's going to give you 3x plus, it's going to give you 3x squared plus, and that's going to give you what? X cubed. And that will be the answer for that. So you see, you've seen how simple it is. So it's not really that difficult. So you just basically knowing the formula and how to apply it. So the same thing, in this example, your A was 1 and your B was X. That's what we did here. So let's pick another example. Let's say we have X plus 4 raised to the power 6, for instance. So our A is X and our B is what? 4. So let's go again. It's going to be X to the power 6, 4 to the power what? 0, plus. We're going to have X to the power 5 and 4 to raise to the power 1, okay? Plus, same thing, X to the power what? 4 and 4 to the power 2, plus X to the power 3 and 4 to the power what? 3, plus X to the power 2, 4 to the power what? 2, sorry, so 4 to the power 4. Okay, I beg your pardon, because the other one has to keep on decreasing. Okay, so let's give it 4 plus X to the power 1 and 4 raised to the power 5 plus X to the power what? 0 and 4 to the power 6. So you can see that you have to keep on reducing. You have the first one, you keep on reducing it by 1, while the other one will keep on increasing by 1. Is that okay? So then with this now, we can now put in the coefficients for the with combination. The first one is going to be, because it's n is 6, it's going to be 6 combination 0, 6 combination 1, 6 combination 2, 6 combination 3, 6 combination 4, 6 combination 5, and 6 combination 6. Now, after this, now we can now go back and solve the question, okay? So 6 combination, remember I told you anything raised to the power 0 is going to give you 1. Anything raised to the power 0 is going to give you 1. So 6 combination 0 will give you 1 multiplied by x raised to the power what? 6 times 1 plus. Now, when you press your calculator, 6 combination 1 will give you 6 multiplied by x5 times 4 to the power 1 plus. When you press your calculator, 6 combination 2, you should have 15 times x4 times 4, 2 plus x combination 3 will give you 20. Okay, when you press your calculator. So this should give you 20, x3 and 4, 3. 6 combination 4, when you press that, it should give you 15. It's going to be 15 times x2 and 4, 4. 6 combination 5, it should give you 6. So it's going to give you 6 times x1 times 4 raised to the power 5 plus, then 6 combination 6 will give you 1 times, that's already 1 times 4 raised to the power 6. So when you press your calculator, 1 times 1 will give you 1, so this is going to give you x raised to the power 6, plus 4 times 6 will give you 24, x to the power 5, plus 4 raised to the power 2 is 16, 16 times 15 will give you 240, x raised to the power what? 4, plus, so you see this other part, you can use your calculator to do it, so it's not hard. So 20 times 4 raised to the power 3 will give you 1280 x raised to the power 3, plus 15 times 4 raised to the power 4 should give you 3840 x squared, plus 6 times 4 raised to the power 5 should give you 6144x, plus 4 raised to the power 6 should give you 4096. And that will be the answer for that expansion. So you can see in this is the first term, second term, third term, fourth term, fifth term, sixth term, and what? Seventh term. Okay. I think that will be that for that. And what I'm going to do, because we're up to 10 minutes already, so what I'm going to do is that in the next video, I'm going to solve more examples, okay? And just to further solidify what we've learned. So I'm going to solve more examples in the next video. After the next video, I'm going to go straight to negative and fractional powers. Is that okay? All right, so I'm going to see you in the next video. We're going to solve more examples on this. All right, see you soon. And please, if you have any question, don't forget to send me a message, or you can comment in the section, in the comment section. And if you also need some questions to be explained, or you need some topics you want me to make a video on, you can put the topics in the chat box, and I'm going to put a video on that. Thank you very much, and see you in the next video. Okay.